Okay, you're welcome to another exciting video on standard form. The last video we looked at what standard form is and how very large numbers are written in standard form. So this is a video that succeeds the previous one. So in case you want to really know what standard form is and how to compute or calculate or convert numbers in ordinary form, large numbers in ordinary form to standard form, you can watch that video first and get a basic understanding of what standard form is before continuing with this one. So let's proceed with this. Smaller numbers involving many zeros can be a problem to write down. That was before standard form was developed, especially the one of negative powers. So before then, it was really cumbersome to write smaller numbers involving many zeros. So thus the standard form for writing them was introduced by scientists. It is easy to write 0.1, 0.01, 0.001, 0.00001. But the more we go, the higher the trouble or difficulty. Some examples are ordinary form. You can see 0.1 is easy. In standard form is 1.0 times 10 to the minus 1. And when we got here, it was really large or very small. So 4.9 times 10 to the minus 7. 0.00062, 6.2 times 10 to the minus 6. You can imagine if you have a number as small as let's say 3.47 times 10 raised to the minus 24, or you can imagine writing down 0.0000000 so you get to 3.47. It's cumbersome. So the use of standard form made everything so simple, or very so simplified. So before the use of standard form, it was very hard writing those kind of numbers in the ordinary form. So scientists have to sit down and come up with a way to write such numbers in ordinary form in a form known as the standard form. So how do we write negative numbers, or small numbers rather, in standard form? So here our movement of decimal is forward to the front of the first known zero digit and not before the first known zero digit. So in the other video where I talked about the movement having to start from the last point, or from moving backwards, rather you make your movement backwards. But in this particular part of standard form, our movement is forward, and we make the movement until we get to the first known zero digit, which is the first significant digit, and drop it there. So it's going to be between the first and the second significant digit. So let's say this number is quite large. Let's look at a number like 0.00245. Take for instance this number. So what this part of this sentence is saying is that our movement of decimal, this is the decimal point, is forward. So we make it forward until, so we move forward 1, 2, 3 until we get to the first known zero. So this is the last known zero, and this is the first known zero. So we drop it here. So when we drop it here, you'll find out that the decimal point is between the first and the second significant figures. The first and the second significant figures. Then once we do that, we raise it to power times 10 raised to the power. The power will not tell us how many times this movement was made forward. This is 1, 2, 3, minus 3. In the other video, it was raised to power 3. That's when the movement was backward. But whenever the movement is forward, it's going to be negative power. That's the rule. So that's how that number was converted, and that's exactly how these ones were gotten from these ordinary numbers. So here our movement of decimal is forward. I underline the word forward, taking it to the front of the first known zero digit. The first, put it in front of it and drop it there. Okay, and not before the first known digit. So you don't do it like 0.00245. You don't say this 0.245 times 10 raised to minus 2. No, that's wrong. You don't put it before the first known zero, is after the first known zero. You put it here. When you put it here, this one becomes no longer significant, so it becomes 10 minus 2. That's what you should do. So let's look at this example. 0.1, you move it to and drop it just after the first known zero digit, which is the first significant figure, and put it here. So in this case, it becomes 1.0 times 10 raised to minus 1, because it was one movement forward that was made. And the next one is 0.01. In this case, the movement will be 2 times 1, 2. We put it here, so it becomes 1.0 times 10 raised to minus 2. 2 movement forward. So note, forward movement of decimal point means negative powers, just like in the other video, backward movement of decimal means positive powers. So anytime we make forward movements, our resulting power will be negative, and when we make backward movement, our resulting power will be, or powers will be, positive. Yes. Okay. Let's look at these examples. Number 1. Number 0.1234566. Okay, so this one, remember that we already have the decimal points here, so we need to move this decimal point forward. So, and we are making that move until we get to the first non-zero digit. The first non-zero digit here is 6, and when we get here, we're going to put the decimal point here. So 26.3. So let's see how many times we need to make that move. So to do 1, 2, 3, 4, 5, 6, 7, 7 times 10 raised to minus 7. I told you that anytime the movement is forward from behind to in front, the power will be negative. But if the decimal point is moved from forward backward, then the power will be positive. So in this case, the movement was done from behind, that's back forward from behind, and it was moved forward, so the power will be negative. So 10 raised to minus 0, and 2, 0.123, 0.00240. Okay, so when we move our decimal points and place it here, this is equals to 2.4. We can ignore the 0 because in this case our decimal point is here, and 0 is the last digit after the decimal point, so it's not significant. You can put it, you can leave it or ignore it, but it doesn't have any impact on the overall value here. 2.4 times. So let's find out how many times the forward movement was made. 1, 2, 3, 4. It was made 4 times. So 10 raised to minus 4 over 2. 0.1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 4, 0, 5. So if we move the decimal point from here until we get to the first known zero digit, which is 4, and put it here, that would make it 4.05 times 10 raised to minus 7. Let's find out how many times that move was made. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 times minus 8. So in this case now, 0 is significant because it's between the first and the last non-zero digit, or the first and the last significant figure. Since it's in between, it's significant, so you must write it. You not we do it in that case. Number 4, 0.1234 1 2 3 4 5 4 2 2 1 equals to, so this will be 4.221 times 10 raised to minus 1 2 3 4 5 6. That's minus 6. Number 5 is 0.1234 1 2 3 4 2 6 5 is equals to 3.65 times 10 is to 1 2 3 4. Okay, so 1 2 3 4 5. That's 5 times minus 5. Number 6, 0.0071. Give us 7.1 times 10 raised to minus 1 2 2 is here minus 2 minus 7 0.1234 1234 571 as equals to, so if you move your decimal points until you get to the first near zero digit, that will be this point, so that will be 5.71 times 1 2 3 4 5 times 10 times minus 5. Number 8, 0.00145 is equals to 1.45 times 10 is 1 2 3 minus 3. So here let's confirm our result. 1 2 3 4 5 6. So that is minus 6. 1 2 3 4 5 6 7 8. That's minus 8. 1 2 3 4 5. Oh, the first no zero digit. Okay, that's minus 4. 1 2 3 4 5 6 7. That's minus 7. That's how we write small numbers in standard form.